Hi friends, today we are going to see the meshing automation using Python. Before that I will explain first the manual procedures and then we can see the automation. Go to the mesh module and then select the length function and apply the length of all the perimeters to unit of 1. Now isolate, make it a little bit. Isolate the radius surfaces. I am giving a value of 200. So in GUI we will be having only the curved surfaces. Since I am going to automate for external aerodynamics meshing, the mesh has to capture all the curvatures accurately. Map visible. You can see some of the surfaces are being unmeshed, so that I am doing spot mesh. Go to the spot mesh, so spot mesh and visible. Now everything is meshed. You can see the mesh is not fine here. That means it is not up to the solver's requirement, but however that is not my aim. I want to demonstrate the use of automation, how it will be applied. And if I invert, I can have the flat faces in another GUI. So for all these flat surfaces I am doing STL mesh, which is visible. So if I click all, I will get my model is done. Okay, so this is what I am going to automate using Python. Open this tool, script and script editor. In that make half. Okay. Go to File, New and New Python script with main function. Either you can select this option or this option. I am going to choose simple script with main function. Okay. So it is launching me with a function. I am just deleting whatever that I don't need. So the name of the function is main, and I have import the OS. I have already imported the OS module and I have imported the ANSA module. A module is nothing but a Python file which contains predefined functions. So from ANSA, which is a module file, I wanna import all its contents, so I import all. So to say that to Python, you need to enter a star, and then I am coming to the function. First of all, go to the topo in ANSA GUI. Go to the mesh and erase all the things. Erase visible. Go to shell mesh, topo module. First I need to collect all the visible faces. So I wanna collect faces. So in here you will get everything. Search. So ANSA contains uh, uh, surface, solid, and points, lines, everything. So everything is a entity. I want to collect face entities, so I am typing entity. Here you can find base dot collect entities. This is the function which I need right now. I will right click on this so that it will be add in that main function. I will open and close the bracket so that within that I can pass some arguments in order to make the base dot collect entities function to work in a proper way. So if you double click that, you can find here the description of the function. The function creates a list with the entities of the specific types. Actually, the first argument needs to be deg. For what solver you are generating the mesh. Actually, I am doing this meshing operation for Nastron. So here itself you define deg is equal to constants dot Nastron. Sorry, constants dot Nastron. First, and if you come to the collect entities function, it needs first argument as your deg, which is defined out of the main function, and then next thing is the collector, that I am putting it as null. I want to collect face. So what is the entity type? That should be passed as a string. Actually, this face is a keyword which is reserved in Python for ANSA's operations. And here recursive, that I will come to you later. Now I am saying to put it as a false, and here it is true. I will this is the synopsis. You need to first type what is the deg, and the next is the container, and one more thing, the third one is the search type, that is face, and recursive, that is as of now it is false. I will explain it later when it is needed. The fifth one is filter visible. That means, do you want to collect only the visible faces? Yes, I need only the visible faces. All the other things like properties from entities and materials from entities and model browser filter, I am not giving any value for these parameters. While creating the collect entities function, whatever that they are passing in these brackets is called as parameter. While using the functions, whatever we pass into this is called as arguments. Okay, please have a clear understanding between these two. So when I do this function, it will return something to me. So what that is? First you need to understand that creates a list. It gives a list. Okay, Python contains many data types. My intention is not to teach Python, but how you can utilize this Python for ANSA automation. If you want to learn Python with other videos which are especially developed for Python learning. So this function will return a list that you should remember. So I am saving this total line of code as face underscore list. So it will collect all the faces. I will double click to enlarge it. So you can see the indentation. That means after this main function, whatever that is coming into that should be shifted right. Okay. So if I print, you can see this is run. Actually what I have clicked is the run. It will execute the function. So it has generated these many faces. Actually it collected all the faces which are visible into our GUI. Print length of this is giving 464 faces we have. Okay, we will check it out whether the program worked very well. So go to faces and info, click and select all the faces. See in the window it is giving 464. So in our script window also it returns 464. So the program is working very well. Next thing, I need to isolate the radius surfaces. Isolate radius. Just right click. To run this function, what are the arguments needed? That we should know first of all. So double click and here it is radius, and that radius should be a floating data type. So I am just giving 200. We will see what happens when we run. See, it just all the surfaces which are having radius within 200. So next thing, on these faces I need to do map mesh. Type map and you can find create map mesh. Right click, double click over there, and here you cannot pass any arguments in this map mesh. Okay, so I am just leaving it as empty and run. Actually the mesh as run, but you need to go to mesh module to view that. You can see now. So if you want to see that thing without going to the GUI, you can add one more step. Base dot current menu, In this you pass MES. You be here too. In GUI I am reverting back. Now I wanna check. Error, current menu with one argument not found. Actually we should not pass anything here. Just print this one. It will say on which module the GUI is. See, now it is in topo. You want to set the current menu. So set current menu. You need to use set current menu, and in that you need to pass keyword mesh. If you do so, it will launch to the mesh module, and it has generated the mesh. Everything is as we expect. Okay, then there are some surfaces which are unmeshed that needs to be meshed by spot mesh algorithm. So I want to get only the unmeshed faces. So how can we get? Type here unmesh mesh dot unmeshed macros. Right click, double click there. What is the parameter argument? Nothing we should pass. Okay, we will check out how many things are remaining to be and need to be meshed. If you run, it is saying 106 macros needs to be mesh. Okay, and that are visible in our GUI right now. Okay, so for these things I need to apply spot mesh. Now run. Yeah, it run. So we have completed our two objectives, and the next one is we need to get only the flat faces. Okay, so if you go to all, now there will be unmeshed which are flat. So again I'm just copying this code right here, just cancelling out this print command, and you can see only the unmeshed surfaces are visible. Now I am doing STL mesh. I am going to do that. STL mesh dot create STL mesh. Yes, that's it. You can see this is STL mesh, and once again you need to paste in your code, and I will erase all the things. Set all erase visible, so no mesh is there, and my module is in topo. I will run this function. So everything worked very well, and there is no unmeshed faces. You can see and check the model. Yeah, thanks for watching. Have a good day.